Question 5 says, if x and y are integers, is y a multiple of 3? Well, to evaluate whether y is a multiple of 3 is the same as verifying whether y divided by 3 yields an integer, right? Yes. When you divide y by 3, you get an integer as a result, as a quotient. Yeah, that means or implies that y is divisible by 3 or a multiple of 3. What about statement 1? It says that y equals the product of 3 expressions, x, x plus 1, and x plus 2. Considering that x is an integer, as per the definition prior to the question, then x plus 1 and x plus 2 must be integers as well. So we have the product of 3 consecutive integers. We might say perhaps this looks too open, that is, an equality with 2 variables that implies infinite solutions. Yeah, but can we really affirm that the fact that there are infinite cases for values of x and y that satisfy the equality, that implies that we don't know whether there is a unique answer to the question? Well, let's see. What do these numbers represent? X is an integer. X plus 1 is the integer that follows, and x plus 2 is the consecutive integer to x plus 1. So we are multiplying 3 integers in a row. Let's see what happens. If you, for example, say that x is 0, then x plus 1 is 1, and x plus 2 is 2. So this would imply that y is the product of 0 times 1 times 2, 0. But when you divide 0 by 3, do you get an integer? Yes, you get 0. So y is a multiple of 3. 0 is a multiple of 3. An affirmative answer to the question. What if x were 1, for example? Y would be 1 times 2 times 3. And we see again that this product of 3 numbers, because it contains 3 already, when you divide it by 3, you will obtain another integer. That is, this is 6. 6 divided by 3 equals 2. So 6 is a multiple of 3, obviously. And so on. If x equals 2, then y equals 2 times 3 times 4. Does this product divided by 3 yields an integer? Yes, if you divide it by 3, you get simply 8. So that is to say, number y would be divisible by 3 again. So it looks like we are getting a steady answer to the question, just a unique answer. So what do? Take a look. If x is any other value, such as, for example, 8, then what would y be? It would be 8 times 9 times 10. Notice that in a sequence of 3 consecutive integers, there is always one of them that is divisible by 3, such as 9 here. So when we divide this number by 3, obviously we will get another integer value. So confirming that the number y is always a multiple of 3. Because 3 consecutive integers, x, x plus 1, and x plus 2, must contain one multiple of 3. That's inevitable. So statement 1 alone is sufficient. What we did here in order to validate whether we obtain always a unique answer to the question or not, we simply try several values until we can see the pattern and conclude that there must be a unique answer. Or perhaps that there must not be a unique answer. But in this case, everything seems to indicate that there is a single answer to the question, an affirmative. So instead of saying not sufficient, we say that this is sufficient. What about statement 2? Statement 2 says that x is a number divisible by 3 or a multiple of 3, but that doesn't relate directly with possible values of y. All we know about y up to this point is that y is defined as an integer, but we don't have any clue as to possible values y may take. So statement 2 alone not sufficient, and the correct answer choice would therefore be option A.